Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve this problem. In this problem it is said that the 400-pound cylinder at A is hoisted using the motor and the pulley system shown. If the speed of point B on the cable is increased at constant rate from 0 to 10 feet per second in t equals to 5 seconds, determine the tension in the cable at B to cause the motion. So to solve this problem, first we have to find the relationship between the acceleration of this point B and the acceleration of this block A. So for that, let me isolate this pulley and this rope mechanism, right? And let's say that we define our two datum lines. Let's say that for A this is my datum line, and for AB let's say this is my datum line, right? So let's say that the position of this point B is measured from this point, and this is the positive sense of the position of this point B. So let's say this is SB, and let's say that this from here to here, this is SA. This is the positive sense of the motion of this cylinder. This is the positive direction of the motion, right? And this length is constant, right? So the position of this cylinder is defined by this SA. So now we have to write the equation for the length of this rope, right? So as we can see that this is SA plus SA. So SA plus SA is 2SA plus SB, and this will be equal to the length of the rope. And if I take one derivative of this equation, so that will be 2 dSA divided by dt plus dsB by dt, and since this length is constant, right, so the derivative of this length with respect to time will become 0, right? So we can say that this is 2VA, this will be the velocity of that cylinder A plus velocity of that point B, and this will be equal to 0. And if we take one another derivative, so then that will give us the accelerations, right? So dVA by dt is acceleration of that cylinder A, plus dVB by dt will give us the acceleration of that point B, and this is equal to 0. So from this we can write that AA, the acceleration of the cylinder, is equal to minus AB divided by 2. So this minus sign indicates that if this point B is going towards the right, that is in the positive sense, so this cylinder will move upward, and that is in the negative sense of this SA. So this is the relationship of AA and AB, the acceleration of that cylinder and the acceleration of this point B. Again we can find the acceleration of this point B. So since we are given that the speed of point B on the cable is increased at a constant rate from 0 to VB, so we can write that VB, we can use that equation of kinematics, that VB equals to VB naught, that is the initial velocity of this point B, plus the acceleration of this point B into t, right? So VB naught is 0, so here it is given that from 0 it starts, so this is 0, and VB is 10, this is 10, so this is 10 AB into t, so t for 5 seconds, right? So this is 5, so AB equals to 10 divided by 5. So from this we get AB equals to 2 feet per second square. So this is the acceleration of that point B. So using this equation we can find AA. So AA is equal to minus 2 divided by 2. So from this we get that AA equals to minus 1 feet per second square. Now if we consider the free body diagram of this pulley along with this cylinder, right? Let's say that now we have this pulley and this cylinder which are attached to each other. So here we will have the tension in the cable which is required. So this is that tension. Since we have only one rope, so we will have the same tension on both sides of the cable, on both sides of the pulley, right? And the weight of the cylinder will be acting downward, right? So this will be the weight. So the weight is 400 pounds. So now we need to be consistent with our positive direction. So this was our positive SA direction and this was our positive SB direction, right? So now my positive direction is downwards, right? So let's say this is my positive Y and this is my positive X, right? So now if I apply the summation of forces along Y equals to MAY to this free body diagram, so as we can see that this weight is acting in the positive Y direction, so I have to write plus 400 minus this 2t, this is acting in the negative Y direction according to this coordinate system, so we need to write minus 2t. So this is equal to the mass of the cylinder. The mass of the cylinder is 400 pounds, so I will write 400. The weight is 400 pounds, so 400 divided by 32.2, that is the G value will give us the mass. This is the acceleration of the block in the Y direction, right? So as we know that the acceleration of this cylinder is AA, and as we know that acceleration is minus 1 feet per second when this point B is moving in the positive X direction, right? So this is minus 1 feet per second square. So we can write that AY is equal to minus 1, right? Or we can say if I multiply this minus 1, so this is minus 400 divided by 32.2. Now we can write that this is minus 2t. If I bring this to the other side, so it will become negative. This is minus 400 minus 400 divided by 32.2. So minus 400 minus 400 divided by 32.2. So this gives us minus 412.42. So minus 412.42, and this is equal to minus 2t. And if we divide both sides of equation by minus 2, so we will get the tension in the cable which is required. So we need to divide that answer by minus 2. So answer divided by minus 2 will give us 206.21. So 206.21 pounds. So this is the tension in the cable which was required, and this tension is equal to 206.21. So this is the solution of this particular problem. I hope you people would have understood this problem solution. Kindly subscribe my channel if you haven't subscribed it yet, and like these videos if you people want me to solve such more problems.